So f of s is Laplace of time domain and is equals to f of t exponential minus s of t dt. We're going to do some question. Where s is a complex number which is given as alpha plus or minus jw. So that's s, right? So you can see here. So example 1. From this workbook, example 1, we are asked to find the Laplace of exponential at. That's the first example we want to do. Let me put this here. If you want to find Laplace of exponential at, we're told that our Laplace transform is f of t exponential minus st dt. What that means is that our f of t is exponential at. So it becomes Laplace of exponential at becomes integral from 0 to infinity exponential at f of t multiplied by exponential minus st or dt. That is what it means. Right? From here, it becomes, if you take it 0 to infinity exponential, t is common here, you can have a minus st dt. Right? Okay. So, this can also be 0 to infinity exponential s minus a. You put a negative here, like this, t dt. Someone, help me out. If you integrate this, what do you get? Anyone? If you integrate this, what do you get? This is a simple integral. Yes. Okay, so this gives minus 1 over s minus a. Am I right? Then we can minus 1 over s minus a multiplied by exponential minus s minus at. That's what it gives, because this comes down. Then you can then have from infinity to 0. Okay, so what that means is we are going to put the values of infinity, t at infinity, and t at 0. That's what it means, right? So that becomes, here it becomes minus 1 over s minus a exponential minus s minus a times infinity. That's when t is infinity. Then minus again, minus 1 over s minus a times exponential s minus a when t is 0. That's what it means. Okay. If this is infinity and this goes to minus infinity, that would be relatively small because exponential minus infinity approaches 0, right? So that means everything here would be 0 as long as s is not equals to a. But, right? Okay. So everything here would be 0. So if everything here is 0, we have, it becomes, this negative and negative will make it positive. 1 over s minus a exponential s minus a multiplied by 0. Right? Of course, here, that becomes exponential 0 is 1 over s minus a. Right? And if you look at your Laplace table, exponential at is 1 over s minus a, which is, which is the second one. I do want to tell you though that if s is equals to a here, the function is divergence. This is only possible if s is greater than a here. Because if s is equals to a here, this will be 0. And 1 over 0 is infinity, right? If s is less than a here, this will be negative. And if you have a negative function, it's divergence, right? So it's x is greater than 0 for this condition. So this is the first one we've derived. That's Laplace of exponential at, 1 over s minus a. And this function is very, very important because we're going to use it a lot. Let's do the second one, which is Laplace of 1. Question before I continue. So Laplace of 1 is going to be, don't worry, today I'll be the one solving mostly. There will be a time for you to solve. So it's going to be integral exponential minus st times 1, 0 to infinity dt. Remember our formula, our Laplace formula is the same. F of t, our f of t is 1 now, exponential minus st dt. So from here, this becomes from 0 to infinity exponential minus st dt like this. Right? If you integrate this, it becomes minus 1 over s. That's what exponential minus st, that's what it becomes. Then you're going from 0 to infinity again. You're going from 0 to infinity. This becomes minus 1 over s exponential minus s times infinity minus 1 over s exponential minus s times 0. So from here, this gives minus infinity. Exponential minus infinity is mostly 0 because it becomes so small. Minus times minus is plus already. So it's going to be plus 1 over s exponential 0, and that would be 1 over s. So Laplace of 1 is 1 over s. As long as our s is greater than 0. Okay. From the Laplace transform table, if you look at number 1 of the table here, you all have Laplace transform table. Like number 1, you will see Laplace of 1, you see 1 over s. Right? That is it. So number 2 is the Laplace of exponential at. And that you will see it is f of t is f over 1 over s minus a. Okay. So let's do question 3. We're going to finish this workbook of t raised to power n. Is that what question 3 is? Right. Again, f of t is t raised to power n. So it's going to be integral from 0 to infinity t raised to power n exponential minus st dt. Right? Great. Who remembers integration by part here? Who remembers the formula for integration by part? Anyone? U dv is uv, right, minus integral v du. Most of you uses it in the assignment, right? So which one do we make u among this function here? Integral u dv. Which one do we make u? Who knows? Most of you are still in the spring break spirit. Anyone know which one from this function do we make u? Which one do we make dv? Who remembers? Yes?
Make the exponential dv.
Why?
Because you already know the integral of that is because it's simple.
Okay, and you make this u because most times we want to reduce this n here. And if you do du, this n might likely reduce, right? Let's see. You might be right, you might be wrong. U is t raised to power n. Our du would be nt raised to power n minus 1, right? Our dv would be exponential minus st dt. V would be, you integrate exponential minus st dt. That would be minus 1 over s exponential minus st. I want to believe you're right. Okay. So if that's the case, our integral u dv is uv, which is this multiplied by this. uv would be equals to t raised to the power n multiplied by minus 1 over s exponential minus st uv, right, minus integral v du. Our v is minus 1 over s exponential minus st, and our du is nt n minus 1. Nt n minus 1 dt. Okay. Let's take a moment to look at this, if it makes sense. Some of you are still like, okay, it's still the spring break. I understand. 0 to infinity there, because that's the limit we're taking. So this becomes t raised to the power n minus 1 over s exponential minus st. You go here from 0 to infinity, right? Minus integral from 0 to infinity minus n over s exponential minus st t n minus 1 dt. Okay. This minus and this minus can change this to plus. Let's make it simpler. So this can be plus. Okay. So if you look at it, if you put infinity, t at infinity here, and t at infinity here, everything here at infinity goes to 0. If you put t at 0 here also, everything goes to 0. So this guy is 0, because if you put 0 here, everything goes to 0. If you put infinity here, everything goes to 0. So this is 0 plus integral infinity 0 n over s exponential minus st t n minus 1 dt. Okay. Question. So what do we do next? Does anyone know what we do next? I need to bring you all back to the spirit of math. Does anyone okay. At least it made us stop falling asleep. I feel like this class is getting boring today. What do you think this is? And it's normal. It's normal because you're not used to doing something like this. It's fine. What do you think this is? Look at this well and tell me what do you think it is. Anyone? Everything here. What can you replace this with? Does anyone know? Who knows? Does anyone know? This guy here is the same, I'm disappointed though, is the same as Laplace of Tn minus 1. Because Laplace of Tn minus 1 is integral infinity 0 exponential minus st Tn minus 1 dt. Okay, so this becomes n over s Laplace of Tn minus 1. The reason why I'm deriving this, I could just give you a table. I'm sure if someone else is teaching you this, they will give you a table. But if I do that, when you're solving differential equations, you will struggle a lot. And then when you get to do process control, most of you will remember me as a bad person and say he did not teach us. He only gave us a table. People do that, yes, I know. You really need to know how to derive this, the basic one. Yes. Okay. So we have established the fact that Laplace of t raised to the power n is equals to this, right? That is what we want to establish. Laplace of t raised to the power n is n over s, Laplace of Tn minus 1. Now, let's look at something interesting. This is where it gets interesting. As you can see, my pacing is very slow today because I really wanted you to understand this. Let's find Laplace of t raised to the power 1, Laplace of t raised to the power 2, Laplace of t raised to the power 3, and Laplace of t raised to the power 4. Let's see what we get. Let's see. for t raised to power 1, it means n is 1. Do you agree with me? Right? So it's going to be, that would be equals to, let's do
1 by
this.
5 L.
That would be equals to, n is 1 over s, right?
So 1 by 5.
Laplace of t1 minus 1. Does that make sense?
Yeah.
So that would be 1 over s Laplace of, what is 1 minus 1? 0. T raised to power 0 is what?
1.
Right? 1. So somebody, what is Laplace of 1? We derived it earlier. What's Laplace of 1? 1 over s.
1 over s.
So this becomes 1 over s times 1 over s. That's 1 over s squared. So we find this one as Laplace of t raised to power 1 is 1 over s squared. Okay. Let's do Laplace of t raised to power 2 now. For t raised to power 2, n is 2. Right? So if n is 2, putting it here again in this formula, Laplace of t raised to power 2 becomes 2 over s, Laplace of t raised to power 2 minus 1. Right? So that becomes 2 over s, Laplace of t raised to power 1. And Laplace of t raised to power 1 is 1 over s squared. That is 2 over s times 1 over s squared. That's 2 over s cubed. So this is 2 over s cubed. Let's do t raised to power 3. We're building something which you will see soon. No, we're not building a house. We're building a thing. For Laplace of t raised to power 3, our n is 3. If our n is 3, it becomes LT cubed becomes 3 over s. L3 minus 1 is 2, t squared, Laplace of t squared. That becomes 3 over s times Laplace of t squared is 2 over s cubed, right? That will become 6 over s4. Is that correct? Okay. That will be 6 over x4. So you all do Laplace of t raised to power 4 and tell me the answer. And let's compare all of them together. So what will be Laplace of t raised to power 4? You do it and tell me the answer. If you don't, just tell me the answer. Okay. Yes.
24 over s fifth.
S
5.
5. Now, if you look at this form a logic, a sequence, right? So this 1 could be 1 factorial. This 2 could be 2 factorial. This 3 could be 3 factorial, right? This 24 is 4 factorial. Look at it, because 1 factorial is 1, 2 factorial is 2, 3 factorial is 3 times 2, which is 6, right? 4 factorial is 4 times 3 times 2, which is 24. So for n could be n factorial, right? Then divided by, this could be 1 plus 1, and n is 1, that's n plus 1. This could be 1 plus 2, and n is 2, that's n plus 2. This could be 1 plus 3, that's n plus 3. So this could be s raised to power n plus 1. Right. So your Laplace of t raised to power n is given as n factorial over s raised to power n plus 1. Okay. And that is on, where is it here? Beta t. I should tell you, Laplace is always in a curly bracket, not a straight bracket like I've been doing like that. So here, the same thing. It is equals to, from 0 to infinity, exponential minus st sine of beta t dt. This is all you need. From here, it's just integral sign. Let me borrow your integral sign. Thank you. So 105 says that if you have integral exponential bx sine ax dx is equals to 1 over a squared plus b squared, right? B sine, this is so long. exponential bx b sine ax minus a cos ax. Yes, that's what it says. Thank you. For those of you that have done it, please help me check this if this is right or wrong. So here it becomes, now in this case our x is our t, right? So let's not get confused. Our b is minus s, right? And then our beta is our a. Maybe I should write it down. So our b is minus s because this is this, right? Our x is our t because this t is our x. Our a is beta. So if we remember it this way, it becomes easier. So what we need to do is 1 over a squared plus b squared becomes 1 over s squared plus beta squared. So it becomes 1 over negative s squared plus beta squared, right? A squared plus b squared. So that's negative s squared plus beta squared. Exponential bx becomes exponential minus st, like that. Then we have b sine ax. That would be minus s sine, our a is beta t, minus our a is beta cos as, which is cos our a is beta t. Put up your hands if you get it up to this point. I want to be sure I'm not making mistake. Great. So let's put the limit. We are still going from 0 to infinity. Let's bring it so it becomes easier. Okay. So let's try and see what we can do to make this easier. I mean, obviously, right now there's nothing much we could do. Let's start with the infinity. This is a bracket here, this is a bracket. If we put infinity, exponential negative infinity here is 0, right? So since this is 0, everything here at infinity becomes 0, no doubt. Do you agree? Everything becomes 0 at that. So let's say at infinity is 0. So limit at infinity is already 0 because negative infinity is 0. So it's going to be limit at infinity is 0, then limit at 0. Let's do limit at 0 would be 1 over this is s squared plus beta squared exponential 0, then minus s sine 0. Again, this is s, not 5. Minus beta cos 0. Now help me out. Sine 0 is 0, right? Cos 0 is what? 1. So this becomes exponential 0 is 1. 1 over s squared plus beta squared. Sine 0 is 0, right? Minus beta. That would be equals to minus beta over s squared plus beta squared. That's what that gives, right? Now let's do the limit. Limit is supposed to be limit at infinity minus limit at this. So the integral is supposed to be limit at infinity minus limit at 0 because it's supposed to be the upper boundary minus the lower boundary. The upper boundary is 0 minus the lower boundary is minus beta over s squared plus beta squared. This is beta. Okay. I want to believe I didn't miss something. Let's see. So the answer becomes beta over x squared plus beta squared. Yes, that is number 13. So that gives us beta over s squared plus beta squared. And that's the answer. Laplace of sine beta t. That's number 13 from the Laplace table. 1, 3, number 13. And if you do the same with cosine, it's the same approach with cosine. You would get s over s squared plus beta squared cosine. So we don't have to do that. It's the same thing. Now, let's do the inverse before we solve one differential equations using Laplace and we end today's class. Let's do the inverse. Question before we move to the inverse. Question f of s is equals to 2 over s squared plus 3s minus 4. no matter what happens, keep your notes on Laplace transform. So if you see, what we've been doing is we've been moving from time domain to Laplace domain. That's all we've been doing. Now we want to do the opposite. We want to move from f of s, which is the Laplace domain, to f of t, which is the time domain. Right. So there are several ways to do it. The simplest way is, what do you call this one? The denominator or the numerator? The one at the bottom. Yeah. You factorize this denominator and then you split it into partial fraction. And then you check the Laplace table to see the one that match. So let's do that first. Let's do the factorization. So if you do that, this becomes 2 over. You find two numbers. If you multiply them, they give 3. And, sorry, if you multiply them, they give -4. If you add them, they give 3. That is plus 4 minus 1, right? So that becomes s squared plus 4s minus s minus 4. You could factorize this. So that gives s into bracket s plus 4 minus 1 s plus 4. So that gives 2 over s minus 1 s plus 4. Can someone check if this is correct? Okay. Great. So that's the first thing you do. Then the second thing is you split them. How many of you have done partial fraction in your algebra? Anyone? Yes.
In high school.
Hassan?
In high school.
In high school?
Yeah.
I didn't take math in high school. Okay. Yeah. Yeah. My high school, I took further math. Not math. Math was very easy in my high school. Yeah. So you split this into a over s minus 1 plus b over s plus 4. And we say it's equals to 2 over s minus 1, s plus 4. We want to find the values of a and b to make this 2. That's what partial fraction is, right? So the way you do this is you can say this is s minus 1, s plus 4. Then this becomes a multiplied by s plus 4, right? Plus b multiplied by s minus 1. Does everyone understand what I'm doing at all? Yeah, great. So let's expand this numerator. So the numerator, if you expand it, it becomes as. This is where I need to distinguish between s and 5. Is this, please? S is black, please. As. Okay. Minus b would be equals to 2 because we're only talking about the numerator. Right. So let's take the ones that have s together, right? So this becomes as plus bs plus 4a minus b is 2. So we can say a plus b bracket s like this plus 4a minus b is 2, right? Okay, great. So we can say this 2 to be 2 plus 0s. 0s is 0. So what that means is you can say this 2 is equals to this. The one with s is equals to s. So that means a plus b with s is equals to 0s. And 4a minus b is equals to 2. We could do that. Yes, it's possible. S can cancel s. So we have a simultaneous equation. And the simultaneous equation is excuse me. 4a minus b is 2. That's what's written there, Sam, right?
Yeah.
Yes. So this is a simultaneous equation. You can solve it any way you want. If you like, you can use a calculator to solve it. It's fine. But in this case, I could just add them together. So that will become 5a plus 0b, because if you add this, it's 2. Our a becomes 2 over 5. Right? Then our b becomes minus 2 over 5, because b is minus a from equation 1. Okay. So now we have the value. Our fraction now becomes, remember, our fraction is a over s minus 1 plus b over s plus 4. So it becomes a is 2 over 5 over s minus 1 plus b negative 2 over 5 over s plus 4. That's what it becomes, right? So that can be equals to 2 over 5 multiplied by 1 over s minus 1 minus 2 over 5 multiplied by 1 over s plus 4. Now look at your Laplace table very well and tell me which Laplace is similar to this. Look at your table. It's similar to 1 over s minus a. Right? So if you look at it in this case, assuming our a is 1. Assuming our a is 1. So 1 over s minus 1 is the same thing as what? Laplace is the same thing as exponential t. Right? Because Laplace of exponential t is 1 over s minus 1. So it means this guy here, the inverse of this is 2 over 5 exponential t. That's what it means. How about this one? Does anyone know? And it changes to plus. That's 1 over s plus 4 here. So that will be minus 2 over 5 exponential minus 40. You really need to remember this because there's so many case studies. With time, when you practice, you will get used to it. Don't worry. So that's the answer. You can see now that we've moved from Laplace domain to the time domain to have t. Okay. We have about 20 minutes more. Try question 2. There is no harm in trying. Try it yourself and see. Our f of s is 3s over s squared minus 5s plus, it's minus 6. Okay. Zoe, do you have questions? Do you need more time? Do you want me to solve it? Or wait? Okay. So let's see. First step, you factorize this and you split it, right? So this guy is the same thing as s squared minus 6s minus plus s minus 6. Yes. Right? Because you need two numbers whose product is negative 6 and whose addition is negative 5. If you want, I could create a calculator to help you do factorization. That way you don't have to think of it. Right? But if we do that, then we don't use our brain again. So that will be s minus 6 plus 1 s minus 6. So that becomes s minus 6 s plus 1. So that's this factorization, right? If that's the case, so this fraction becomes a over s minus 6 plus b over s plus 1 because I already split this. This is the first step to do it. Then the second step is we need to find the value of a and b. Right. So it becomes 3s over s squared minus 5s minus 6 is, if you do this, this becomes a multiplied by s plus 1 plus b multiplied by s minus 6 divided by s plus 1 s minus 6. Right? Okay. So let's expand it. Let me jump steps here to make it easier. This is AS and this is BS. It could be A plus BS like this. This one. And this is A minus 6B plus A minus 6B. And we equate everything to what is at the top here. Right? Because that's what we do. Which is 3S plus 0. So the rule is the one with S, you match them with this. The one that does not have S, you match 3. If S cancelled out. And a minus 6b is 0. I know I jump step, and that's because we're trying to beat time. So this is a quadratic equation. You could just subtract them. A minus a is 0. This becomes 7b. Because b minus minus 6b is 7b. Is 3. Our b becomes 3 over 7. Right? And we know our a becomes 3 minus b. If you bring this here, it's 3 minus b. So our a is 3 minus b, which is 3 minus 3 over 7. And if you do that, you would get 18 over 7. Because it's 21 minus 3. So we have our a and b. So let's bring it back here. If you bring it back here, our fraction becomes a is 18 over 7 multiplied by 1 over s minus 6 plus b is 3 over 7 multiplied by 1 over s plus 1. We know that this is exponential 60. The inverse exponential 60, because we know that Laplace of exponential at is 1 over s minus a. If a is 6, so this becomes s minus 6 here. So that gives 18 over 7 exponential 60, and this gives exponential minus t, plus 3 over 7 exponential minus t. So that's our answer. That's how we got that. We have 12 minutes. Let's use that to, you can say this is equals to 2s minus 3, s squared plus 2s plus 1 plus 3 squared. Do you agree? That's the rule. Now, you can factorize this guy now. And if you factorize this guy, it's the same thing as 2s minus 3. This is s plus 1 squared plus 3 squared. Now you can start solving for me. I've split the first part. So you can go from here now. I'll let you continue from here. Looking at your Laplace function, which one is closely similar to that? That's what you start looking at. If you go to Laplace function, if you go to Laplace of sine function, that is number, if you go to number 22 and 23, let me write it down. You will see that they are similar. Number 22 is EAT sine KT is K over S minus A squared plus K squared. While this one is EAT cos KT is S minus A over S minus A squared minus K squared. This is S. Okay, great. Thanks. Now, this comes to my mind. This is S plus 1 plus A squared. You could see that both of them here, they have the same, right? Except that the one here has S, and the one that has S is this one. But it has to be S minus A, but this is 1. So it means this S has to be S plus 1, right? For it to work. So the question is, what do you need to do to this guy to be S plus 1? That's the question. So you can say, I want to make this guy S plus 1. So what do I need to do? You can say, I want to add a function, add a number, P, to make it S plus 1. So I can say 2 into bracket, instead of this S, I put S plus 1, right? Plus P, which is P I want to add to it, right? Then will be, so that it will be the same as this, 2S minus 3. So let's find what P would be, because we want to make this S plus 1. So that will be the same here, so that we can use this as the inverse. That's what we're trying to do. And so it becomes 2S plus 2 plus P is 2S minus 3. Right? This guy can eliminate this guy. So P is minus 5. Right? So what that means is we need to take 5 out of this to get this function. So this function now will be replaced with, everything here will be replaced with, instead of 2s minus 3, it's going to be 2 into bracket s plus 1, then plus p, remember, which is minus 5 over, we have s plus 1 squared plus 3 squared. That's what it becomes. And then it makes sense, because if you evaluate this, it's the same as 2s minus 3. Because this is the same as 2s plus 2 minus 5, which is 2s minus 3. So what we have just done is we've replaced this 2s minus 3 with everything here, so that we can have this same function here, and we can use this Laplace here. Now we can easily split this into 2s plus 1 divided by s plus 1 squared plus 3 squared minus 5 over s plus 1 squared plus 3 squared. Does that make sense? Yes, we can split that, even if you disagree. Question. Some of you are looking at me as if I'm doing magic. It's not. Okay, great. This guy here is the same thing as 2 multiplied by s plus 1 divided by s plus 1 squared like this, plus 3 squared. Do you agree? Great. And remember, for this function, before we can use this guy, it has to be k, the number here has to be the number here. Right? Of course, this one we can use it directly because this is s plus 1, this is s plus 1, so we could use this one directly. But for this one, we can't because this is 3 here and this is 5. So we need to do something to make this number 3. What can we do? Anyone? If you multiply this by 5 times 3 divided by 3, it's still the same. 3 over 3 is 1, right? Then multiply by, this becomes 1 over s plus 1 squared plus 3 squared like this. So that becomes 5 over 3 multiplied by 3 over s plus 1 squared plus 3 squared. There you go. We have our function. So the inverse of this one would be, look at it, s minus a. If our a is negative 1, this becomes the same as this, right? So it's going to be exponential at. And our a is negative 1, so it's exponential minus t, right? Cos kt, k is 3, right? Cos kt. So that's for this one. Question? Yes. Right.
In the 5 and the 3, is that a plus?
Which one?
Right up in the green on the board.
I'm coming. This one is plus. I missed this one. You guys should have told me it's plus. Is that what you're saying?
No, the other side. I'm just asking what the sign is.
Which one? This one?
No.
This one?
Yep.
It's multiplication.
Okay.
Sorry. Thank you. Okay. So the inverse of this, if you look at it, if you compare it to this, is going to be exponential. So it's going to be exponential minus t, minus at, right? A is minus 1, right? So minus t cos kt, our k is 3, that's 3t. That's this one. Then minus, remember there is a 2 there, we can put the 2 here. The 2 is still there. Then minus 5 over 3. This one is the same as this guy here. Because k is 3. So it's going to be exponential minus t again, sine 3t. So that's our answer. So our answer becomes, thanks for it. Our answer becomes 2 exponential minus t cos 3t minus 5 over 3 exponential minus t sine 3t. Okay. Great. Question. If t raised to power n is n factorial over sn plus 1. We know that. Right? So this guy becomes, n is 2. So it becomes 2 factorial over s2 plus 1. That would be 2 over s cubed. That's for this guy. For this guy, you could say it's the same thing as 7 times 1. Right? And that would be 7, which will times Laplace of 1. We know Laplace of 1 is 1 over s. That's going to be 7 over s, like this. S, not 5. Please. My s and 5 looks the same. I know that. Plus, who remembers the formula for Laplace of cos 2t? It should be, is it k over s squared plus k squared? What is it?
S over s squared plus k squared.
S over s squared plus k squared. Thank you. Our k is 2 this time, so it becomes s over s squared plus 4. So this is your answer. Right? Then for this guy here is the same. For number 3, it's still going to be Laplace of 3 minus Laplace of exponential minus 3t. That is what it's going to become. And Laplace of 3 is 3 over s. Right? This is 3 over s. S for Sam. S for Sabrina too. Okay. Then minus, what's Laplace of exponential? I don't know. Who knows? What number is it? Yeah, what's exponential? Laplace of exponential is 1 over s minus a. Thanks. So that would be Laplace of exponential is 1 over s minus a. But a is minus 3. So that would be 1 over s minus 3. This one will give us 3 over s minus 1 over s plus 3. Did anyone get this answer? Okay, great. So we are going to look at how 0 is 1, y prime of 0 is 0. Does anyone know what kind of differential equation is this? Let's start. What kind of differential equation is this? Let's start with the order. What's the order? Yes, second order. Great. Linear or non-linear? Yes, linear. Okay, it's a second order linear, homogeneous or non-homogeneous? Why is it homogeneous? Yes, Sabrina. Yes, because it's equals to 0 here. So it's a second order linear homogeneous differential equation. Great. All of you have this, right? Go to page 2. If you go to page 2, the box there, you have number 1, 2, 3. Look at number 3 and 2. It tells you the Laplace of a derivative. That's what you need, because what we're going to do is, this guy, to solve this, we take this guy, we convert it to Laplace domain. After we convert it to Laplace domain, we are going to solve for it. Then we convert it back to time domain. That's how we do it. That's how you solve it. You take this, you convert to Laplace domain, you solve, then you take it back to time domain to get your answer. Now, the tricky thing is, to convert to Laplace domain, if you look at page 2 on your workbook, you have the Laplace of a derivative. Both first derivative, second derivative, third, and on like that, right? So it means that this is a second derivative, we have the Laplace of it. This one is the first one, we have the Laplace. Let me write it down so you see. So for first derivative, you have something like this. Is SF minus f of 0. That's what you have. Then for Laplace of the second derivative, you have s square f of s minus s f of 0 minus f prime of 0. Right? I hope I'm correct. Yes. It's second derivative, so that's what we have. Okay. So we are going to take this, using this formula now, we convert all of them to Laplace. Let's see. So to start, this is y prime prime, this is a second derivative, so we take this guy. So everything here to Laplace transform becomes s squared, right? F of s. Who has a better marker? Then minus s f of 0 minus f prime of 0. That's for this guy. Then plus 3y prime, it becomes plus 3. This is for y prime. So it becomes 3 you do s f of s minus 3 f of 0, right? It's just 3 multiplied by this and multiplied by this. Then plus 2 times y. So that would be plus 2. What would be Laplace of y? Does anyone know what Laplace of y becomes? Does anyone know? Let's see. Anyone knows what Laplace of y is? Check the table and tell me. Let's see the table. Check the table. Table 2 and tell me what Laplace of y is. Remember, Laplace of y is y of s like this. That's what it is. Right? From the table. Okay. So now that we have this, let's start evaluating. We've converted everything to Laplace transform. Let's start evaluating. Right? So this becomes s squared, right? F of s. That's what that becomes. Minus s times f of 0. So in this case, what's our f of 0? Does anyone know what our f of 0 is? Everyone is quiet. Why is everyone quiet? Anyone know? What's our f of 0? Yes?
Is it 1 from the initial division?
Yeah. So f of 0 is y of 0, right? because our function is y, right? Okay, actually, let's do it this way. Let's say s y of 0, because function is y, right? Minus fy by this one becomes y prime of 0. Let's make everything y so it becomes easier. So we use it. Then plus 3s y of s minus 3y of 0 plus 2 y of s. Let's do that. Let's remove the f and make. So what this function means is y. So that becomes easier. So we are told that y of 0 is 1 and y prime of 0 is 0. So here is y of 0. This is y of 0. And this is y prime of 0. Right? This is y of 0. So let's replace it. We're told. So this becomes s squared y of s minus s y of 0. We're told y of 0 is 1. That's minus s times 1. Minus, we're told y prime of 0 is 0. Minus 0 plus 3s y of s minus, we're told y of 0 is 1. Minus 3 plus 2y of s. Right? And remember that everything here becomes 0 because that's what we're working with. Question before I continue. I just want to be sure everyone is following. Okay. So this is y of s here. This is y of s. This is y of s. We can put them together, right? And this is s. This is 3. So let's put the y of s together. So that becomes s squared y of s, right? Plus 3s y of s here, which is this guy, plus 2y of s. Then let's take this one together. This is minus s minus 3 would be 0. Right? So we can bring y of s out here. So if you bring y of s out, it becomes s squared plus 3s plus 2, like this. You could take this to this other side, becomes s plus 3. Okay, this is where it gets tricky. I'll take a pause here and see if you have question or you feel like I missed something. I want to believe I didn't miss anything because it's easy to make mistakes. Let's see. Okay, I think we're good. So our y of s becomes s squared plus 3s plus 2. S squared plus 3s plus 2. So we find y of x, right? So we inverse this and that will be our solution to the differential equation. This is now in the Laplace domain. Our solution is y of t. So we take the inverse. Now let's take the inverse of this. Remember, this is in Laplace domain now. So we need to convert it back to time domain to get our answer. So to do that, we already know how to take the inverse of the function. This becomes s plus 3 over, you factorize this. That would be s squared plus 2s plus s plus 2. That becomes s plus 3 divided by, you have s plus 2 plus 1, s plus 2. S plus 3 divided by s plus 2, s plus 1. This is a ridiculously long question, you see? Compared to the one you just do quadratic equation. I know that's what you're thinking. But once you have non-homogeneous, Laplace is better. And you must know how to use this formula anyways. So let's split this. Remember how we used to split. We say this is equals to a over s plus 2 plus b over s plus 1. And then we find a and b. That's how we used to do it. So let's do that. So this becomes s plus 1, a multiplied by s plus 1 plus b multiplied by s plus 2. Okay. And then we have it as, let's take the one s together. So this is as plus bs. That would be a plus b like this s. And this is a plus 2b plus a plus 2b. And then we equate it to everything here, s plus 3, like we used to do, s plus 3. So what that tells us is that our a plus b is 1 and a plus 2b is 3. Right? Okay, question. Just do, this is b is 2, right? 2b minus b is b is 2, right? So a would be minus 1 because, I hope I'm correct. Is that correct?
Yes.
Okay, so we have a and b, so we put it back there. So it becomes a is minus 1 over s plus 2 plus b is 2 over s plus 1. Now, we know what this is. The Laplace transform of inverse of this. This would be, for this guy, the inverse is minus exponential minus 2t. That is what it is. For this one, it is 2 exponential minus t. So the answer, our y of t, our solution is minus exponential minus 2t. Okay, great. Now I'll let you do question